Welcome to this talk. My name is Pieter Cailliau, and today we will be talking about real-time currying and aggregating time series data with RedisTimeSeries. This is a co-host talk by myself and Danni, the creator of RedisTimeSeries. On the agenda for today, we'll talk about time series, how time series data is traditionally modeled within Redis, and what RedisTimeSeries adds on top of that. Then Danni will take over and he'll talk about aggregations across time series data within RedisTimeSeries and the architecture for that. And he'll also give a brief demo about that. About myself, I'm produced in Belgium. In a former life, I was a software engineer at TomTom and a consultant at Neo4j. I'm currently leading the developer capabilities product team at Redis Labs, and I do believe my dog is a unicorn. So what is time series? Time series data. According to Wikipedia, a time series is a series of data points indexed in a time order. Most commonly, a time series is a sequence taken in a successive equally spaced points in time. Thus, it is a sequence of discrete time data. And we can see an example of time series on the right-hand side. So now, why are time series database management systems growing in popularity over time? If you look at the DB Engine's website, and over the past 2 years, we can see that the rise of popularity is growing very fast. And why is that? Is because there is a growing trend of use cases, time series use cases. The most commonly known ones are application monitoring, but also, for example, historical data about the weather. But with the rise of new use cases such as autonomous driving, real-time bidding, smart homes, and more and more online retail applications, all of these new use cases, they also produce tons of time series data. And they need to be managed within a database management system. Within RedisTimeSeries, in the traditional way, you could do that in two ways. One is the combination of a sorted set with a hash. So in a sorted set, effectively, the members are sorted by the timestamp, but each member in the set needs to be unique. That is why, effectively, the member refers to a field within a hash, which contains then the time series value or values. Another way to model that within Redis is by using streams, and each message in a stream can effectively represent a sample within your time series data. And Redis streams effectively use Redis tree to index that data over time. So, but what is missing in those two ways of modeling time series data within Redis? First of all, there is downsampling. Downsampling effectively applies when you have the older your time series data becomes, the less relevant it is to keep all the samples, all the raw samples. So you could apply some aggregation effectively to do the compaction of the amount of data you have within your database. You can do that with the traditional ways, but you will have to write that yourself client side. There is no compression. Time series data lends itself very well to be compressed. For sure, when time samples, for example, are equally spaced within time. There also no support for enhanced queries out of the box. For example, aggregation or aggregation across time series data. And also, there is no easy way to query your time series data. There is no secondary index out of the box within Redis on top of that time series data. And effectively, all those capabilities are what RedisTimeSeries adds on top of Redis. It comes with its own data structure, which allows for compaction, for downsampling, and aggregation over time. RedisTimeSeries also has support for several integrations and ecosystems, such as there is Prometheus, Telegraph, Grafana. With Grafana, we have a direct connection called the Redis Grafana data source, which allows you to access data within RedisTimeSeries, but also all other data structures within Redis directly. And in the previous hackathon, somebody also wrote an integration towards Slack, so you can effectively have a Slack bot that allows you to query data within RedisTimeSeries. With regards to benchmarking, we always wanted to support or be fully supporting the TSBS. TSBS is a time series benchmark suite, which is created and maintained by several industry-leading time series database vendors, such as Influx, Timescale, and MongoDB. what this benchmark effectively does, it has a series of queries and ingestion stress tests that stress all the time series capabilities for a given use case. And when you support all these queries within the benchmark, you could effectively say that you support the biggest common denominator of all time series database management systems. So we're working on this, the support for this time series benchmark suite, and we already have some preliminary numbers when comparing on the ingestion rate, Redis time series, InfluxDB, and timescale. We can see that with regards to the throughput, Redis time series is up to 2.7 or 3 times faster than Influx and timescale. There's also a test, of course, with regards to reads, but we didn't support the complete picture. To support the complete picture, we were missing support for 5 queries, and these 5 queries, they have a single thing in common that we were not supporting. And Danni is going to talk about that a little bit more in details.
Thank you, Peter. Hi, my name is Danni Moiseyev. I'm a principal software engineer in Redis Labs. Unlike Peter, I was produced in Soviet Russia, and I've been working on Redis TimeSeries and Redis Enterprise for the past 4 years. Also, unlike Peter, I believe that my company and my coworkers are the real unicorns and not his dog, although I must admit his dog is a bit cute, but is not as awesome as my coworkers. So before we dive into the details of the new features, I want to go over our data model and talk a bit about how it looks from the inside. So in this example, what we see on the screen, we have 2 keys. We have key 1 and key 2. So this is a part of Redis. So Redis is based on keys. So first of all, we can see that we have 2 keys, and when we look inside of each of those keys, we can see that the Redis time series keys, it looks a bit different than other data types. What we're basically doing, we're splitting the data into different chunks. So if you think about a time series is a series of samples. So we take the samples and we use chunks to store them together. So a specific chunk will hold data from timestamp A, for example, up to timestamp B, and the second chunk will hold data that is basically bigger than timestamp B and up to a specific timestamp. So all the series itself is split into different chunks. We're doing that for performance reasons. There's 2 reasons for that. One, if we look at memory compression and the size of the data, we want to compress the data. And to be able to compress the data, we need some context. And this context actually contains in the previous samples. So each sample is basically built on top of the other samples to be able to compress it. So using chunks, we can better utilize this mechanism and compress the data much better than other techniques. The second reason is memory allocations. We want to optimize for speed, and we don't want to allocate a lot of data all the time, so we pre-allocate a chunk and then use it until it's full. Those chunks are indexed internally per each key. So if we have a very large key, we can know exactly which key to go to if we're looking for a specific timestamp or a time range. On top of that, we also have a secondary index. Our secondary index allows us to go and index specific keys with specific labels. In this example, you can see here that we have 2 labels for each key, and each label is basically a key value pair. So you can pick any field you want and any value you want to tag your keys. We are doing that because later on we can query the data according to these labels. So for example, we can say, okay, bring me all the keys that are from a specific region and are from specific zone or are not from a specific zone. This is crucial metadata that allows us later on to actually create a multi-key queries. Okay, so let's look about how we query data in Redis TimeSeries. So the first query is the most simple one. We have a key. We want to get a range of samples from a specific timestamp, a start timestamp, and up to the end timestamp. This is very simple. We just get the data as is. The second one is a bit more complex. we're saying give me the same data from a specific start timestamp up to a specific end timestamp, but I will also want to aggregate the data to using a specific bucket. In this example, this is 1 hour, so it's 36,000 seconds, and I want to aggregate those samples into 1 hour buckets, and for each bucket I want to take all the samples and aggregate them using an average. You can also use different aggregation function. In this example we're using average. So the second query will return much less data than the first query because we are aggregating to 1 hour buckets. Now the third query is a bit more interesting. Unlike the first query where you must give the query a specific key, in the third query you don't really need to do that. In the third query we are using a filter. A filter basically it's a query to the secondary index. In this filter, for example, we're telling the secondary index give us all the keys that are coming from a specific region, in this case US East 1, and for each key do the same aggregation as we did in the previous query. So the second query will return us a single key response, and the third query will be 0 keys or X number of keys. It really depends on the data itself. So if we have 1 key, we're gonna get only 1 key. If we have 10 keys that have this label, we're gonna get 10 keys. And this allows us to do much more complex stuff, and it really depends on what kind of data you are using. You don't really have to use that, but if you need to, this is really awesome. And the latest query that we are basically implementing in the next version is the mRange with GrewBy. So if we talked about the third query where you get multi-key response and each key is aggregated, let's say you want to do something more complex and take that result and aggregate it even further. For example, if you want to see all the results from a specific region, but you want to group them by the zone, and you want to take the maximum per each group, which is a specific zone, and see only that. So basically what you're seeing here is very similar to the third query, but we create a GrewBy. And by doing that, we're gonna get even much smaller result than the third one, because it will not be per key result, it will be per group result. So if we have only 2 zones in US East 1, or we have 5 zones, we're gonna get only 2 or 5 responses. And this allows us to have a much more complex queries and allow our customers and users to do more complex stuff with Redis TimeSeries. So let's dive in on how aggregation works and what is actually aggregations. So let's look at the most simple one. Okay, this is the second query that we've seen in the previous slide. And in this query, we're basically telling the Redis, give me a specific key from a start timestamp to an end timestamp and aggregate it by, in this case, 1 minute. So what we see here is that we first cut through and find the specific time range that we're interested in. We don't look at the timestamps before this timestamp and nothing after the end timestamp. So we're only looking at a specific time range. And for that specific time range, we're gonna bucket it. We're gonna take all the samples for each bucket. In this example, the bucket is 1 minute. And we're gonna create a specific sample for that bucket. So the result will be actually 3, in this example, which is very simple. It will be 3 samples in the result, and each sample will correspond to a specific bucket and will be the average of all the samples between an example for in this one, in the first one, T1. The result will be a sample with all the values aggregated using average between T1 and T2, and so forth for T2 and T3, and this is how we're gonna do the simple aggregation. Now we talked a bit about having a GrewBy. So by doing a filter, we can take a multi-key filter and respond with a multi-key response. But with a GrewBy, it's a bit more complex because you need to first fetch the keys and then do more complex stuff after that. So to make it simpler to understand, we're gonna split it into 4 stages. The first stage is the most simple stage. We're gonna fetch the keys according to the index, to the secondary index. So we're gonna take the filter, we're gonna execute the filter, we're gonna find all the keys that are relevant to the query. Then we're gonna group them according to the group by element in the query. We're gonna aggregate each key as we did in the simple aggregation, and then we're gonna reduce the groups into a single series per group and do the reduction function. So let's see how it looks like. So the first stage is basically finding all the keys and fetching them and grouping them. So in this example, I have 4 keys that are relevant, and I'm grouping by the region. So I have 2 regions in this example. I have US East 1 on the left side and US West 2 on the right side. And basically, when I aggregate by region, I will get 2 groups. So 1 per region. And the response will be a 2-key response, or 2 result set response, and each region will be part of the response. So I will have 2 time series once I query the data. So the next stage is taking a specific group. For example, in this example, we're taking the left group, the US East 1 region, and we're gonna do the 3rd and the 4th stage. Which is the 3rd stage, we're taking each key and we're doing the same aggregation as we did in the previous slides. We basically go over each key and we bucketed it and make it simpler to reduce. And then in the 4th stage, we're gonna take all of the samples that are aligned between the different keys, and we're gonna reduce them using the reduction function. So in the example that we wanted to see before, we used a max aggregation, but you can use other reduction function. It's up to you, whatever you need according to your data set. Just to make it simpler, I just use the max here. So in this stage, basically, we're taking 3 samples from T1, and we're gonna take the maximum out of 3. And for T2, we're gonna do the same, and for T3, we're gonna do also the same. And this is how we're gonna reduce a single group of 3 keys into a single series. So this is very simple if you are using a single shard database. But what happens if you have a multi-shard database and you want to use a distributed command? And this is where a neat feature that we have in the next version. Basically, what we're doing, we are leveraging Redis gears to have much more complex queries that you can run on your cluster, and you can utilize the Redis cluster to do those things for you. So you don't really need to go for each key, for each shard, and aggregate the data and do the group by or whatever you want by yourself. You can just load Redis with RedisTimeSeries and with Redis gears, and it will just work together. And what we're gonna see in the next slide basically is how we're gonna do that. So if you remember the first stage where we fetch the keys, we find the keys, and we fetch them to process them in the 2nd and 3rd and 4th stage, in a multi-shard cluster, what we're gonna do, we're basically gonna use Redis gears to fetch those keys for us. So it doesn't matter which key which shard you're gonna pick to do the query. Each shard that is loaded with Redis gears and with RedisTimeSeries, basically you can query with mrange or mget or query index. So those 3 queries are distributed across the cluster. And each time you're gonna run this query, basically we're gonna use Redis gears behind the scene to distribute the first stage and get all the keys, all the relevant keys with all the relevant data. It means that we're not pushing data between the shards that is not relevant for your query. So everything before start timestamp and above end timestamp will not be shifted around the cluster. And once this data is coming back to the initiator shard, which in this example is shard 3, we're gonna perform the 2nd, 3rd, and 4th stage to actually perform the aggregations and reduction and grouping of your data. Okay, so next up is the demo. Okay, so I will start by connecting to my cluster, and basically I have a 5 nodes cluster in this setup. So we can see we have 5 slots. So let's start by looking which keys I have on this specific shard. So I see I have 30 keys coming from host 1, 5, 9, and so on. Now let's look at a specific key. Doesn't really matter which one. Sorry, TS info. So we can see we have around 6 different labels. So let's actually query the index and find all the labels, all the keys that have this specific label. These are supposed to bring us all the keys that have this label, and this is basically all the data that I have from the TSBS loaded into this cluster. So we can see we have 100 keys, but if I'm looking at this specific shard, I have only 30. So by doing this query, it's already been transmitted around the cluster, and I actually got a multi-shard response for that. So let's do something more complex. So let's say I want to query all the data from all the keys and from all the shards, basically. So I got 100 responses by doing this query. So what this query actually mean is that we're taking a specific range. We have a start timestamp and an end timestamp. We're aggregated using a count aggregation for a 1 hour bucket, and we're filtering the same filter that we did before. So we saw that we already have 100 keys, and I now see that I have a 100 keys response, which is pretty cool because these are coming from multiple shards. This is not a single shard. Just again, if I do a keys asterisk, I can see I have only 30 keys on this shard. So let's continue. And the next one that I'm gonna do a group by. So I'm running the same query that I ran before, just with a small difference. This is the first query, and this is the second query. So I'm grouping by region, and I'm doing a reduction of a max. So let's run this query. So I got 7 responses. Unlike before, we got 100 responses. So basically, we've reduced the data to 7 groups. So I have 7 different regions in my data set. Now, to look to have a more information about the metadata, I can add a specific flag to the query called with labels. And once I run that, I can also see who participated in that specific group. So you can see that in this key, which is actually it's not a key in Redis, it's a time series per region, so it's a virtual group of sort, and we can see that we have one label, which is the region that we are selected to the group, and we also have the function, the reduction function. We can see that it's a max, and we also have the source, and the source tells us which keys participated in this group. So if you remember, the second stage is the grouping stage. We group those keys into this specific group. And you can also do different queries. For example, if I want to do a TS get for this specific key, I cannot, because it's on a different shard. I need to go to that shard and connect to that shard and do that specific key. But with an mget response, we can do something more complex, because we already have Redis gears to leverage our multi-shard queries. So I'm doing a TS mget, and I get 10 responses for that. And the reason I did this query is because you can see this is a host-free query. It's coming from a specific host, this key, and I wanted to get all the keys that are coming from that specific host. So to get that specific key, I will need to add another label, and that's the field name usage guest. And now I have the key that I tried to access before, but I access it for a different shard. So sometimes this is less optimal than going directly to the key that you want, but if you want to do a multi-key get, this is very useful, because you don't really need to know on which shard it's located. You can just access any shard you want and just run your query. Okay, and if we're going back to the mrange command, so in this example we have another mrange command. So in this example we can see we have a max reduction, but we can also use different reduction. For example, we can do sum, or we can do minimum. So you don't you can use whatever best fits for you. Okay, that was basically the demo, and now I want to talk a bit about performance. So in the last few weeks we also did a performance benchmark on this solution. And just to give you a sneak peek, and for a specific query on TSBS, you can see that we are on par with the most performant databases out there, and we are a bit better on some queries. And this is only one of them, and we're gonna publish all of our benchmark in the next couple of weeks. This benchmarks is part of the TSBS benchmark suite. The only thing we did is added RedisTimeSeries support to TSBS and use that. So stay tuned. This version is coming up really soon. Private preview will be coming in May. If you want, you can communicate with us, and we will try to get you in if you want to get access to the private preview. Thank you, and I hope you enjoyed. You can contact us on our website or on our Discord channel. If you want, you can also try Redis Insight, which is a cool UI for Redis. If you're into that, enjoy and have a good time.